Okay, guys, we're going to learn about open delta, and what open delta is a transformer type. Okay, guys, but there's some stuff I haven't been telling you about three-phase, guys, and the reason I haven't been telling you about it is because it didn't matter up till now. We've been doing three-phase transformers and three-phase loads and RLC series loads on three-phase circuits, etc., etc. And there's this little detail that I left out, and I'm going to share that detail with you now. And the reason I'm going to share that detail with you now, guys, is because, well, now it matters. Because once we learn about open delta, this is going to matter. So have a look here, and don't, worry about it too much. Don't draw, don't draw this. I just want you to watch this, guys, for a second. So this is a Y-connected load, guys, and we know with Y there's two things that are true, right? I line is equal to I phase for Y connected, right? So any line current I have here is also going to be the phase current, right? And then E line, it's equal to E phase times root 3, right? So those two things are true about, Y. Now imagine here that this is a resistive load, right? So is that. So imagine this line here being I phase, the current flowing through that, resistor, right, guys? I phase. Well, if it's I phase, that is also going to represent the phasor for I line because they are equal. So I could actually say this is also, I line, right? I phase or I line. Now, that's cool, but let's take a look at E line for a minute. Now, if I took, two of these phasors and tried to figure out what, the voltage from line to line would be, it would be the phasor sum of these two. And if I drew, those two phasors, let's get some good colors out here. I phase, guys, let's, imagine I phase being this phasor right here, okay? And then we take this guy here, and it looks like this, right? And the sum of the two, guys, is going to be a line that goes from, let's get a brown marker here to here. So what this is E phase for one phasor. This is E phase for the other phasor. The sum of those two is equal to E line, which is right there. And what I'm trying to show you guys here is if I drew this line voltage on here, it would look like this, okay? Like that. There's E line. And, I'm drawing all this stuff here so that you know that even though this is a resistive load, and a resistive load causes the voltage and the current to be in phase in the load, and they would be, okay? If I took at if I, scope the voltage from here to here on a scope, E line, and I scope the current right here from this load, I line, on, if I took a look at those on an oscilloscope, guys, I would see that there is a actual 30-degree phase angle difference between the line voltage and the line current. And so if I scope those two guys, it would look like this, okay? Here's E line. And here's I line, okay? And that would be 30 degrees. Now, that happens with every single Y-connected three-phase load, guys. If you have a three-phase load that is a resistive load, in other words, in phase at the load, the fact that it's three-phase causes the voltage and the current to be out of phase in the lines by 30 degrees. And that's just, because of the way it works. All right, guys? Now, some students say to me, well, is that going to, ruin my power factor? I had a nice unity power factor in my load, but it's out of phase by 30 degrees in the lines. Is that going to ruin my power factor? And the answer is no. And the reason it's not going to ruin the power factor is because whatever transformer you have here, guys, that's feeding this load is going to also be three-phase, Y or delta. And yes, the voltage and the current will be in phase at the load here, it'll be out of phase in the lines, and it'll be back in phase, in the windings of the transformer, secondary. It'll be in phase at the windings of the transformer on the primary. It'll be out of phase on the lines feeding that transformer, all the way back to Bruce Nuclear, guys. And then it'll be back in phase at Bruce Nuclear. And the people who are supplying us energy, guys, they don't care about the phase angle in the lines. They care about their phase angle at where they're being generated, where that is being generated, okay? So really quick here, guys, what's happening here is a three-phase load that is in phase will cause the line voltage and the line current to be out of phase by 30 degrees. All right, but it'll be back in phase in the windings of the transformer, be out of phase in the lines feeding that transformer, and in phase, in the windings of the machine that's generating the voltage. Now, the question is, does that only occur in Y-connected three-phase systems? And the answer is no. It actually occurs in all three-phase systems. And so we know that this guy is delta, right? So let's see if we can remember the rules for delta. E line is equal to E phase, right, guys? And I line is equal to I phase times root 3. Okay, so those are my two rules for delta. And so if I took a look at, let's say, as phasors, okay, the voltage from line to line here, well, the phase voltage, would be a line looking like this, okay, E phase, and E phase is equal to E line, so I could also say that this is E line, okay? Now, if I took a look at the currents here in the same spot, I would have an in-phase current here and an in-phase current here. These are both I phase. Okay, but the sum of those two, I'd have to take this one. Well, let's do this one. I'd have to take this one and put it, here, all right, tip to tail. There's that I phase. I know this is small. Okay, guys, sorry about that. And I line is the sum of the two. There is I line, that brown line right here, okay? So what I'm looking at here is E line, it's E phase and E line, this purple line, and there is I line, okay, guys, for this line right here. And so you can see that even on the delta system, a in-phase delta load will cause an out-of-phase line and current, okay? And again, at the transformer secondary, it'll be back in phase, primary back in phase, in the lines feeding the primary back in phase, all the way back to Bruce Nuclear, where it'll be, in the line feeding the transformer will be back out of phase, okay? And then all the way back at Bruce Nuclear, it will be back in phase. So, why am I telling you this? Well, it doesn't really matter, okay? It doesn't change any of the calculations we've made so far. Okay, so don't worry about it. Don't think about it too much. It's just a fact, and it's a fact that doesn't really matter, but it does matter a little bit when we look at the open delta transformer, which we're going to do in the next video.